Okay, first off, I want to thank Vincent and Dan. Those were amazing talks. I'm going to expose my ignorance here and that I do not have a lot of experience within visual AI. So I am a developer advocate for Elastic. Previous to that, about 5 months ago, I was a developer advocate for Redis. So I'm a little bit more on the vector embedding side, the vector search side. So this is all very amazing information that I've been exposed to, and I'm really excited to start playing with this with Elastic. So, I am Justin Castilla, Senior Developer Advocate at Elastic. Thank you very much for having me. This has been a lot of fun to explore and learn some new things, and I have a lot of plans with Voxel 51 and Elastic as I continue on. So, what does this talk about? Basically, I deal with a lot of data sets and working with vector embedding as use cases, and I'm kind of tired of either using PDFs or text samples and things like that. So this opportunity to use images is actually really interesting for me. And one use case that I think is very fun and interesting and has a lot of different dynamics is birds for images. So birds have a vast set of unique visual qualities. Everybody has some bird that they think is kind of interesting, and they're just kind of fun to look at. So of course we could use this as a placeholder for any other data set. By the way, this is what was it? Chestnut-backed chickadee in the Olympic National Park. I took this picture. So yeah, look at all these birds. They're wild looking, right? They're very dynamic. They all don't look the same. Have different sizes, colors, shapes, textures. They have a different habitat. Where are they? Up in a tree, in the water, in the desert, in the jungle, and they have different behaviors. So we have on the top left, of course, an ostrich, which is up 6 feet tall, hundreds of pounds, and you have in the center left a bee hummingbird which is able to sit at the end of a pencil eraser. So they're all very amazing. They're all very cool. And I think it's a very interesting subject to use for vector embedding and image recognition and image prediction. So what did I do first? I went to Kaggle and I pulled a large 6 gig sample of birds. 525 different bird species in the named folder, 100 to 200 images each. Each image was 224 by 224, so that was actually quite nice. Keep the data set relatively low, large amount of birds in a lower data set. And then also included was a CSV file with name and scientific name and a image path to the associated file in the folder. Unfortunately, I learned that a lot of these birds were misspelled. So Mandarin duck was Mandarin duck. Red-tailed hawk was red-tallied hawk. So that actually created a bit of a halt in my development to actually create like some quality information with this proof of concept. Also, there's a lot of birds named after people's names. So Brandt's cormorant, Abbott's sea catcher. They all have to have apostrophes to actually be recognized or found online. So if you're trying to cross-reference some information, we need those. And then all caps. That's great for processing a lot of data, but when you're kind of like wanting to show this to the public, you want to have these capitalized. So I ended up doing a little bit of that. So I cleaned the bird data, a lot of scripting heaven, capitalized all the bird names, all these scientific names that went with them. Also, I connected to WP Tools, which is a Wikimedia client for Python, where you could actually submit a name or the Wikipedia entry name, and it would spit back to you the actual object. So you can actually get the description or the metadata of what you're looking up. So that was actually really helpful. I could blindly iterate through all of the birds and request their name. If they got back, great, the birds are recognized. If not, then the odds are something is odd with that name. So I did have to do a little bit of visual inspection. I don't mind because I like birds, so it actually worked out really well for me. So I corrected the unverified names, the ones that came back from WP Tools saying, I don't know what this is. And I made sure that they all aligned with Wikipedia and Wikimedia so I could actually pull out some data from Wikipedia and create a more interesting, larger corpus of data. This is a great-eared nightjar. Kind of horrifying looking. Okay, so aside from me playing with bird data, how does Elastic actually fit in? Well, Elastic is the company behind Elasticsearch, so that it's one and the same. We power search, logging, observability, open telemetry is a new friend, and then security and analytics. But right now, we'll of course focus on Elasticsearch. Elasticsearch has always offered traditional search, so BM25. And then we have also offered now flexible vector search platforms. So one of the cool things that I really like about Elasticsearch is that you can create things mostly all through API, either programmatically on your computer with a client, or you can actually go on to Elasticsearch's site, and there's very different methods to actually create an index. So here I am creating an index for a bird document, basically. It'll be stored as JSON in the data store. So I'm going to have name, scientific name, description, which is a paragraph of text I pulled from Wikipedia about the bird. And then here's my image embedding. So you can have it as a dense vector, well, for images. You can set the amount of dimensions that you want, whether or not you want it to be indexed, and then what similarity algorithm you can use. So you can use cosine dot product L2, or you can actually define your own algorithm as well. With text embedding, you can also do sparse vectors. We have a couple different models that we also have, but we actually can host other models if you actually want to integrate that into your ingestion pipeline, which is actually something I'll talk a little bit later. So I have this image index going on, this bird image index. And I apologize, this looks like some red string on a wall deep under a basement, but this kind of just goes over my process of what I did to get this data. I took the Kaggle data set. I took the CSV of misspelled names, cleaned them up with WP tools. I also embedded locally, and that's also a little point of contention for me. I embedded locally these images that were from a separate folder using clip vit b32. I combined the paragraph I pulled from Wikipedia, the original bird data that's been capitalized, and the image embedding into a document. And then I inserted it into Elasticsearch. Now, one thing that kind of irked me is that I couldn't host an image embedding model on Elasticsearch. Usually you can with text embedding, and it's very convenient, very nice. You can just throw as much bulk input into Elasticsearch, and it will actually process your data and spit out the actual vectors on their machines. That's really, really great because I don't have the strongest laptop. And I just want to be able to throw things up there really quickly. So I'm actually creating a PR to allow a few select image embedding models to start to have as pre-trained models within Elasticsearch. So let's take a look at a little bit of code. This is the Elasticsearch Python implementation. So first, I'm just going to take an image path of the common Grackle. I'll open it up with PIL, and then I'll call encode with my sentence transformers model, and then convert it to a list, because that's how Elasticsearch likes it. Very simple stuff. Now, with Elasticsearch, I connect to it. I create a simple dictionary with my bird information, so name, scientific name, image path, image embedding. And then I also use bird description. I also include that in there by calling WP tools, and then that's the little script to actually pull the description out of that Wikipedia entry for that bird. And then lastly, I call esbdb.index. I state which index I want to use, and I just throw the bird into the body. Sounds a little bit weird, but yeah, basically I just pass the bird in. So this is just one document into the index. So of course, I'm going to want to do a bulk because I had 84,500 approximately birds that I needed to enter in here. So this is our client command to actually add in bulk our documents. So it's kind of an interesting way. We create a large iterable where each object has one line where we're saying we want to index them to the index updated birds, which would be an index for birds. And then we actually include after that in sequence the bird document. It's kind of non-intuitive, and I'm still not the happiest about it. As a dev advocate, I can kind of chide them about it, but it is what it is. And I send it in batches of 500. and it throws it up into Elastic with nary a problem. So to reiterate what happened for visual learners, I'm a visual learner, so this is a lot easier to look at. I have a bird. I want to query this bird. Like, do you know what this is? Elasticsearch, do you know what this is? So I'm going to embed it with my sentence transformer model. I'm going to query it with Elasticsearch. So it'll do a vector similarity search. It'll spit back a result. It'll say, oh, that's a common grackle. And then since I actually have a little tiny app to demonstrate this, it'll show me the image path that I can use. And I can pull up that image path, and there is the common grackle. And I can verify that because I know it. So let's actually show a vector query in action for Elasticsearch. A lot of this you'll see is similar to creating our original embeddings. So I have the temp image, I open the actual query image, I create the embedding of the image. And this KNN, K nearest neighbor, I'm just creating the query object for vector search. So image embedding is what I'm going to be searching through, 5 of the nearest neighbors, and then I want to see a total num candidates of 100. Also a boost of 100, that's just going to alter all the return values so I can actually have an interesting number coming back that I can show very quickly. Lastly, that fields array is going to say, I want to get the name, the scientific name, the image path, and a description back from you. That's all I want, nothing more. And then at the bottom, you'll see all of that wrapped together. es_db.search. I'll pass in the index, the query body, which includes the KNN, and the fields under source. All right, so let's actually check out some of the code in action. This is for image recognition of birds. So I'm going to drop in a couple bird JPEGs just in ping files just to actually see the capabilities in action. So this is a grackle, common grackle. I'm going to actually embed this, send it to Elasticsearch, and I should receive 3 of the most commonly similar bird images. So let's see what we have here. There we go. So we have common grackle is number 1, brewer's blackbird number 2, and then a crow is number 3. So basically a black bird. This is pretty accurate. Now, one interesting thing is previously in the talk, I said the boost of the scoring was multiplied by 100. So this is the similarity value, and I just multiply it by 100 and just threw it up here just to show you the confidence score of what these are. So let me try another bird here. Let me just refresh this. We have this interesting bird, and I purposely took screen captures of video of birds because it's kind of hard to find bird photos online that aren't already in this image compendium. So I have this guy, and it looks like we have a Pyrrhuloxia, or an African firefinch, or a Pyrrhuloxia. So I'm guessing that we're going to have a Pyrrhuloxia. And again, you can see definitely some visual inspection. This is definitely working. Let me do one more just to keep things in triplicate. What do we have here? So we have a red-winged blackbird, very pretty sounding. Let me give that a try. And there we go, red-winged blackbird, then tricolored blackbird, and then fan-tailed widow. Let me show you real quick. So Elastic, this is the user interface for it. This under search, I'm able to see the indexes that I have created. So here we have updated birds dev. I say I have 83,720 documents. I can go in there, do a quick little inspection. I can see the different documents in there. So here's an example. I have a cockatoo. Everybody has those around. Has the description. And I can also visually inspect the image embedding if I so choose. You can check out the image mappings. So how do I actually have my index mapped out? So if something surprising happens, I can kind of troubleshoot with this. So you'll see like name is also keyword multi-field. So I can treat it as text and keyword, whereas description is a paragraph. So there's no point in actually doing a keyword search over description. Lastly, there are pipelines. I didn't use a pipeline within this project just because there was no real alterations to create here. I wanted to create some normalized data before I actually sent it in because I'm going to share this normalized data back with Kaggle saying, hey, I cleaned up some of this data that was misspelled. So, but this pipeline is good for if you're using embedding for image or for text for now, you can actually have it embed your text into vectors. And again, I'm going to create a PR to get image embedding allowed into our pre-trained models. And just to show a little bit more, so here I am. This is the actual API that you can interact with on the page. It's called DevTools. And this is just the API put, and I'm creating a new index right here. I'm not sure if I created it previously. So here's just another one. I'm deleting the index, and here's going to create a new one. So this is a really great sandbox to actually get to know your application. So let me do an actual search, golden crowned kinglet by name. And there we go. So we're going to get all these different results back very quickly. It's very unfortunate I actually don't have the application running, but I promise you it did work. It's kind of funny. Lastly, you can connect your data. Elasticsearch, it does a very fast data store, but we're also trying to help you out while you're actually working on your data. So I have an LLM connected to my Elasticsearch. I can have it connect to some of my indexes, and I can ask it a question just to do some quick checks. So I'm right now using 3.5 Turbo, keep things inexpensive. Who is Carl Linnaeus? I think that's his name. So there we go. This is actually not actually working with the image embedding because I can actually have OpenAI work with that. I actually have to have a better model, a visual model to work with that. But I can actually go through the description text. And so it's pulling out some text about Carl Linnaeus from the description text I pulled from Wikipedia and put it into the birds. So, and that is going to be my truncated demonstration. Sorry about that. So further developments. I would love to add a live aspect to this. I have a beautiful window in front of me next to some bird feeders. I'd love to connect a Raspberry Pi camera right outside the window, train on a bird feeder, and then identify those birds. I see Voxel 51 has some excellent capabilities for that, and I'm actually really excited and trying to go a little bit faster so we can hear Steven talk, because I really want to hear about his Elasticsearch Voxel 51, the client. So I want to see a notification pop up on my screen or my phone whenever there's a new bird species that I haven't seen yet, come up onto my bird feeder so I can take a look at it. I'm creating a PR to include image models and Elasticsearch trained models because we host trained models. So not just ours, but any that you can bring. Right now it's text. I want it to be image as well. I want to enhance this data set with more information, so visual descriptions, some stats, some numbers, some citing, things like that, so you can actually cross-reference and ask it, hey, I'm in Oakland, California. What birds are near me? Or what is a great place to go in San Francisco to find a lot of birds? Turns out it's Land's End or Golden Gate Park, or Fisherman's Wharf if you're really into seagulls. And lastly, there's only 525 species of birds in this data set. So I need a lot more birds. So I need to find more quality sets of bird information and bird images. And then lastly, the whole motivation behind this was this little app that I picked up during COVID. I got into birds and I tried the Cornell Lab Merlin phone app where you can actually use audio sampling to listen to birds and it'll spit back to you what bird it actually hears. So before I sign off, please check out that code. It does actually work, I promise. It's just I was too overzealous in making sure that my computer was quiet, and so I closed, of course, my IDE that was running it. But yeah, check out the Elastic Bird repository. Also, come check me out on Twitter, or send me an email if you'd like, or go on over to Elastic's community Slack if you ever have any questions. I'd love for somebody to take a look at this code and see if you have any feedback as far as how I can improve the performance or the accuracy. Because I just did basically blind out of the box vector similarity search. So I'd love to hear some feedback from the experts in the room. Also, lastly, this is the Sirocco parrot, otherwise known as the party parrot. We have him in our Slack channels at all times. So thank you very much.